Hi y'all! The video that I'm going to be uploading today is to show why the tilt of the Earth can determine things like whether or not there's an eclipse, seasons, things like that. So we're going to go ahead and get started. I'm going to ask you first, if you happen to have with you two spheres of different sizes, look around. You have maybe a baseball sitting somewhere and a basketball or even a ping pong ball and a marble, something like that, because as I've always said, if I'm going to be demoing something for you, it's always best if you have something you could demo along with me. It'll kind of clarify some things with you. So if you do have two spheres and a light source, it could be an open window, it could be a lamp, things like that. Today, for me, for your lab, I am going to be using a balloon and a cue ball. The cue ball is from like a pool table. A little bit in different sizes because one is going to represent the Earth and the other is going to represent the moon. So the first thing we want to do is take our larger sphere, and what is that imaginary line? That line you probably learned in geography that separates the northern hemisphere from the southern hemisphere. Do you know what it's called? It's called an equator. So the first thing we want to do is go ahead and draw in our equator. Drawing on a balloon is lots of fun. There you go, just like that, and I'm going to label it equator. Equator. All right, how's that look? You got it? Okay, cool. So to clear up a misconception, most people, or a lot of people, think that the Earth rotates. Oh, you know what? I forgot. Let me show you some vocabulary. First of all, I'm going to use words like rotate and revolve. I'm also going to use words like orbit. So watch me. You ready? We did this the other day, but remember? Rotate, spinning in space like this. Revolve. Rotate is spinning like a top. Revolve is moving around something like a sun or something like that. Another planet, etc. So a lot of people think that the Earth rotates straight up and down like this in relation to the sun. This is going to be my sun. So a lot of people think that it rotates along the equator, but it doesn't. If it did, theoretically, then the moon, which remember is linked tidally, T-I-D-A-L, by its tides, tidally, to the Earth, if it did, then we would have an eclipse every single month. We would have the moon passing between the Earth and the sun every single month, and we know that doesn't happen. Eclipses are relatively rare. We'll talk more about eclipses here in a second. One reason why we don't have an eclipse every month is because the Earth is tilted. It's tilted at about 23.5 degrees. All right? Doesn't spin on its side per se, but it's significantly tilted, which then causes the moon to revolve this way. So rarely does it actually pass between the sun and the Earth. Are you with me so far? All right. Now what's cool is if you watch this and you just for a second hold it like this, you can really see on your smaller sphere how the sun hits the moon and where it hits the moon. And if you remember, at all times, half of the moon is lit up. We see it as a crescent or a gibbous or something like that because from our perspective, looking at the moon, it looks like it's changing. And if you do this yourself, you'll be able to see it, and it's pretty cool. Does anybody remember what that line is, by the way? That line, the delineating line between day and night, the line that shows half is lit and the other half is not? It's an Arnold Schwarzenegger movie. Do you remember? Terminator. All right, the Terminator line. It shows the difference between day and night. It shows the difference between the light and the dark side. All right, so here we are with the moon. It's rotating like this. Now, just for fun, I'm going to go ahead and use my incredible artistic ability, and I'm going to draw for you the United States of America. There you go. Isn't it beautiful? The United States of America, just like that. And X marks the spot. That's Nevada. So when you're looking at this, I want you to really watch what's happening right there, because that's where we are. All right. So first of all, it's spinning. What is spinning? What's the scientific word for spinning like that? Okay, it's rotating. So the Earth rotates completely in about 24 hours. So when it's facing the sun, it's day. When it's facing away from the sun, it's night. That makes sense. And you can look at your large sphere just like that as it's tilted, and you can see that half of my sphere is illuminated and half is in darkness. But what about seasons? What does this tilt have to do with seasons? Well, it's like this. The same amount of energy is coming off the sun, and that same amount of energy is going to hit the Earth in different ways. If I'm leaning towards the sun, like the Earth is leaning towards the sun, the energy from the Earth is going to hit here first. It's going to hit here, and that same amount of energy that hits here in one spot will be the same amount of energy that hits here and is scattered all the way through that entire other hemisphere. So if it's leaning towards the sun, it's going to be summer. You get it? It's going to be hotter. A lot of people think that it's summer because the Earth is somehow closer to the sun. No, it doesn't work that way. Earth stays relatively the same distance away, but it leans. So here we are at the equator, and here we are right here in Nevada, and we're leaning towards the sun. So whether it's day or night, we're still leaning towards the sun. We're facing the sun during the day, but we're leaning toward the sun even at night. Okay, that whole point of your axis is leaning towards the sun. Now the Earth does not wobble back and forth, but it does revolve around the sun. So as it revolves, it's going to stay in that same tilt, that same 24-degree tilt. So here we go, around the sun, still tilted. Do you get it? So here it comes. So how long does it take for the Earth to travel all the way around the sun? About 365 rotations, about 365 days, or Earth days. 1 year. That's what we call a year, a trip around the sun. All right, so here we are in Las Vegas in the summer. Bam, he's leaning towards it. It's daytime, great. He's spinning day, night, day, night, day, night in the summer. But now he's moving, still staying at that 24.5-degree axis. When it gets to about here, where's the majority of the energy hitting? Is it hitting the top? Is it hitting the bottom? Not really. It's kind of hitting everything sort of equally. You know, they call it an equinox. When you have your equinox, that's when fall is or spring is. So if you're looking here and this is summer facing toward it, as it revolves around and it gets here, now we're in fall. Because after summer, all the leaves fall. Now it's going to move farther around here. And now, what's pointing towards the sun? The southern hemisphere. So now it's summer in the southern hemisphere. The northern hemisphere, right here in Las Vegas, now it's winter. Still spinning, 24 hours takes for a complete rotation, and now it's spring. Still at that same slant. And now it's facing the sun again, and it's summer. All right, so what controls the seasons? The tilt of the Earth. So this is where it kind of gets cool. When we think winter here in the United States, when we think winter and we're pointing away from the sun and it's winter, it's Christmas time, Santa Claus is going to come, and we picture Santa Claus on a sleigh and reindeer and snow. But in Australia, down here, at Christmas, Santa Claus arrives riding dolphins and riding a boogie board or a surfboard. Because in Australia at Christmas time, it's summer. So don't think just because here in the United States it's winter throughout the world. It's not. Your hemispheres divide your seasons. Your northern and southern hemisphere. So when it's summer in the northern hemisphere, it's summer throughout the entire northern hemisphere. When it's winter in the southern hemisphere, it's going to be winter in the entire southern hemisphere. And then when it comes to day and night, it's divided equally. So it might be summer in Las Vegas in daytime and summer in Mexico in daytime. In daytime in Mexico here, you turn it backwards, now it's nighttime. Now it's nighttime, but it's still summer for the United States because we're still tilted towards the axis. So here we go around 365 days all the way around. All right, now this is what you guys get to do. You are going to diagram this. You're going to draw a picture of this. How are you going to remember this? This is how I would suggest, but you do it however it makes sense to you. On my board right here, I have the sun. Now remember, 1 billion Earths can fit inside the sun. So this is not to scale, okay? It was not to scale. 1 billion Earths can fit inside the sun. But I want you to take your marker or pen, or if you want to do this digitally, that's fine. And you're going to go ahead and draw your Earth. Now I want you to draw your equator. And remember, the equator does not divide across here. It's at an angle because the Earth is on an axis. All right, so we're spinning. All right. Now wait a minute. I showed you a little while ago how eclipses don't happen every month because it's on its side. But how do eclipses happen then? Well, first of all, it's not going to happen when we're tidally locked in the midst of the middle of the summer or the middle of the winter. It's going to happen when the orbits line up. When does that happen? Every few years. It's not really as predictable as you would think, but as it's coming around on those times when we exactly line up. So here's Las Vegas, right? When it exactly lines up during its orbit around the Earth and Earth's orbit around the sun, when everything, oh yeah, no eclipse here, no eclipse here, no eclipse here. What is this? Everything perfectly lines up. When everything perfectly lines up, the moon is directly between the sun and the Earth. Then if you're in Las Vegas looking this way, I mean, use your small sphere and roll that in front of your light source and you'll see a shadow cast on your larger sphere. Do you see that? Can you see it? So here's my moon and it's going to cast a shadow on my Earth because the moon is going to pass between the sun and the Earth during its orbit, right? That's called a solar eclipse. It's called solar because I'm looking at the sun. Don't look directly at the sun, but I'm looking at the sun. If my head was the Earth now, and the moon blocks out my view of the sun, and I'm in shadow. Cool. What about a lunar eclipse? Well, do you think a lunar eclipse happens when the sun comes between the two? No, if the sun gets that close, we all vaporize and we're dead. So no, that's not it. So what is it? Well, here we go. Same thing. Every now and again, everything lines up perfectly, but this time with the moon away from the sun. And when the moon is revolving and it's away from the sun and it's just perfectly lined up, the sun shines across the Earth and the Earth casts a shadow on the moon. So a lunar eclipse is when the shadow of the Earth covers the moon. Again, it doesn't happen often because of the tilt, but it happens often enough that I guarantee you'll be able to see several in your lifetime. All right? So thank you very much. If you have any questions, comments, or concerns, make sure you reach out to me through my email or a comment on Google Classroom. And thanks for joining me, and I hope you learned something.